Today, I want to talk about one of the most important or interesting solid design principles, which is the dependency inversion principle. Uh, and let's try and understand it with an example to see how it leads to a more maintainable and extensible system. We'll also look at dependency injection pattern and see how it is different from a dependency inversion principle. So let's start with an example. Let's say you are building a application and you want to implement logging in it. So one of the most simplest ways of implementing logging is to just log to the console. So one way to do that is to have a class like such. Class console logger, and it can have a method like print to console. I will take in a string in argument, and it can have the whatever code that is in there. And the way you would use it in your client class is, let's say you have a client class like class client. You'll first create an object of this logger that we just created above, console logger cl equals to new console logger cl. And let's say we have a do work method here where we do have our business logic. Yes, do work. Here we can use our logger like cl dot print, and we can pass in whatever log message we had to pass. Now this works fine, but let's say tomorrow you decide to have a file based logging system instead of a console based one. So to do that, you'll probably add a new class called file logger like such. Class file logger, and let's say it has a method like append, because files you have to basically open the file, add a log statement to the end of the file and then close the file. So basically you're appending at the end of the file. So append, it again takes a string message argument, and it has a necessary code to do just that. Now the way you would use this file logger in your client class is, so you'll have to basically change this line to now say read file logger fl equals to new file logger. Okay. And now since your file logger has changed, you have to change this line as well, because it does no longer has the print method anymore. So you'll have to do file logger dot append and append whatever you are appending. So if you notice, your client is a higher level module where you are writing your actual business logic and you're doing all the core work here. And the lower level modules like the console logger or the file logger, they are providing services to the higher level module. Now, since because of this tight dependency that you have, your client is dependent directly on the implementations of the actual loggers. Your lower level modules, whenever they change, your higher level modules are forced to change, because they have to adapt to the changes that are happening here in order to keep functioning forward. But so if I have to draw the dependency graph, so it is client, and you have your file logger, and your client is directly dependent on the file logger. So any changes here will force a change in the client. Now let's look at what the dependency inversion principle states. uh, so dependency inversion principle states that no two concrete classes should directly depend on each other. Okay, let me just write it down. No two concrete classes should directly depend on each other. Instead, they should depend on each other through an abstraction. Okay, let me just write that down as well. Instead, Now let's see what this means by just copying the dependency graph again. Okay, so we'll still have the client class, and we'll still have the file logger class here. And we also have our console logger. So, so the client cannot directly depend on the logger implementations, as the debate principle states that they should depend through an abstraction. So, we can think of having an interface. Let's call it the logger interface in between these two. So, logger. Now, your client will depend on the logger, and your file logger as well as your console logger are just implementations of the logger interface. Now notice dependency inversion principle does not actually remove the dependency. You can never actually remove the dependency, because if you depend on something, you depend on something. You cannot function without it. The dependency inversion principle instead it states that you should depend through an abstraction. So let's see how this will actually improve your code base by starting with the logger interface. So let me just write it down. Interface logger. Let's say it has a single method called log, and it takes in the string message. Now let's see the file logger implementation. So we'll have file logger implements the logger interface. So whenever you implement an interface, your compiler will force you to implement all the methods that are declared in the interface. So we'll have to implement the log method here. So void log string message, and we'll write our implementation logic in here. Now let's see how our client class will change. So we'll have class client. Now earlier we used to create an object of the actual loggers with the actual loggers like console logger or file logger, but now if you notice a client depends on the logger, so we'll just create a variable of type logger L equals to new. Now we can create an instance of any of the actual implementations of the log interface, which is file logger or the console logger. Now this works because in OOPS you can store an object of your child class in the parent class reference. So now we still have the void do work method, void do work, and we can do l.log. Now we'll have the log method from the interface, and we'll just exit it. So this is what we have implemented in the dependency inversion principle. But now let's say if you have the same requirement as you had previously, now we wanted to add a new type of logger. Let's say you were using a file logger. Now let's say for some reason you want to switch back to a console logger. So what you would do is you create a new class called console logger, make it implement the logger interface, and then implement the necessary methods, which is the log method in this case. And then we can simply come over here to the file logger, change this line. Instead of file logger, you can now just create a console logger object. And since it implements the logger interface, you can store its object in the logger type reference variable, and rest of your code will work as expected. So this is how your interface, because your interface guarantees that all the child classes will at least have the log method, and since you are relying on the interface here and you are relying on the log method of the interface, it is guaranteed that the rest of your code will work as expected without any further modifications. Now let us look at the dependency injection pattern. Dependency injection. So dependency injection is a way of achieving dependency inversion There are many other ways, but today let's focus on dependency injection. So it basically says that uh, any class should not create its dependencies on its own. So here, if you notice, we had used the new keyword to create the dependency of the logger interface, and we are using that throughout the class. But you should rather depend on, you rather just you accept that dependency, advertise advertise that you to the external world that you depend on a logger interface, such that some external entity will provide you that dependency at runtime. So let's rewrite the client class. So class client, we'll still have a variable of type logger to keep store that, and now we can accept that dependency from an external source. Now the one way to accept the dependency is through the constructor. So let's just write that public client logger L, and we can do this dot L equals to L, and we'll have a other code here. Now the benefit of doing this is, no, okay, before coming to the benefits, let's just see. We asked, through the constructor we are accepting an object of type, which is of logger type. Now some external entity or your consumer, or let's say the consumer of the client class, is now responsible for providing the necessary logger implementation to the client class in order to create an object of the client. So that way your client is completely decoupled from what logger object you are going to get at the end of the day, because it does not care, like as long as the object that is received here, it follows the logger implementation, it is good to go. uh, so let's not worry about what that external dependency is that is going to give you the logger object. Just assume that there exists a genie or some sonpari that will probably give you the object at runtime. So let's talk about the benefits of this, or the advantages of this pattern. The very most and the most important advantage is testability. Now that we are accepting the logger object in the constructor, and not creating the object ourselves. If you are ever writing a unit test case for the client class, you can simply create a mock object of which follows the logger interface, or you can create a test double and simply pass that along to the pass it along in the constructor. That way you can mock the dependencies, and you can easily listen in for the usage of those dependencies. Let's say you can use the Hamcrest library to listen for the calls to this for to the methods of the logger. Then you have something called maintainability and extensibility. Okay, so now let's say you have that file logger implementation, right? So let's say there is a common feature in file based logging systems. It is called as rolling log files. So a rolling log file, it basically says that if a log file exceeds a certain threshold size, let's say for 1 MB or let's say 5 MB, it basically closes that file, creates a new file, and then starts outputting the logs to that new file until that new file reaches a 5 MB, and then it creates a new file, and so on and so forth. So this rolling log file feature you can easily implement with here, where you can basically have your logic of creating and checking the file sizes, and then creating a new file and starting writing to the new file in the file based logger. As long as you have the log method intact, if you do not touch the log method, and if you can add any new features, any new you can maintain these existing features easily. So that way your system is more extensible and maintainable, because the changes to implement the rolling log file feature are localized to the only to the file logger class, and those changes are not affecting the rest of your application. Here we can also see the application of open close principle, because you are able to add this new feature of rolling log files in the file logger without actually modifying any existing code base. So your code base was open for extension but closed for any modification. So that is it for today's class. Thank you for watching, and I'll see you in the next one.